All right, we are now looking at target 7b, to find the trigonometric ratios for acute angles in a right triangle and calculate sine, cosine, and tangent ratios when given two side lengths. So remember, we have sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We also often write this as SOHCAHTOA, right? That's our kind of way to remember it. SOHCAHTOA. Okay, so number 6, identify the ratio of cosine C. Remember, with all these problems, our first step is to label our hypotenuse, our opposite side, and our adjacent side. So your right angle is always where it looks like it's the floor and the wall, right? That's what a right angle is. And across from that is our hypotenuse. That's always the one we should label first. Then, this is talking about C, okay? The biggest issue I saw in a lot of our quizzes or activities that we were doing was not looking at what angle we had to use. We would just choose a random angle, okay? It's very important. You have to do what the question is asking. So I have to look at angle C, and across from that is my opposite side. And then right between the angle and the right angle is your adjacent side. So the cosine of C equals A over H, right? It's adjacent over hypotenuse, the ka part of SOHCAHTOA. So my A is 10, and my hypotenuse is 15. And we're always going to check if we can reduce. 10 over 15 does reduce to 2 out of 3. 2 over 3. Okay. All right, looking at number 7, identify the ratio of tangent of A. Okay. So again, A is our angle. Where's our right angle? Again, where it looks like there's the floor and a wall. Okay. So across from our right angle is our hypotenuse. Across from the given angle is our opposite side. And between the two is our adjacent side. So if I'm finding the tangent of A, again, that's the TOA. So tangent of A equals opposite over adjacent. My opposite side is 27. My adjacent side is 36. I'm going to type this in my calculator, and I get 3/4. And make sure you're always reducing our fractions. That's another big mistake that we forget to do it at the end. All right, looking at 8. Identify the ratio of sine of theta. Okay. So theta is here. Here's my right angle. This one's already marked for you. And sine of theta is, right, it's the SO part of SOHCAHTOA, right, opposite over hypotenuse. So, across from our right angle is hypotenuse. Across from our given angle is the opposite. Between the two is the adjacent side. Okay. So, sine of theta equals O over H, opposite over hypotenuse. My opposite side is 18, and my hypotenuse is 24. Again, I'm going to type that into my calculator to check if it reduces. And it's 3 out of 4 again. That's fun. Alright, so all 3 of these are literally just writing your fractions. Let's look at number 9. If cosine of theta equals 40 over 41, find sine of theta. Okay. So first, draw a diagram. This triangle will not be given to you. You are going to have to remember that you do have to just draw a diagram. It means just to draw your right triangle. Okay? Make sure you put in the right angle and theta somewhere. Okay. Then again, the first thing I'm going to do is I'm going to label my sides. I have the hypotenuse, my opposite side, and my adjacent side. Okay. Once I do that, I need to figure out what numbers I have. So cosine of theta equals 40 over 41. Remember, cosine is adjacent over hypotenuse. Okay, so just reading right across, adjacent side is 40. My hypotenuse is 41. Okay. So there's my diagram. That's all the information I have been given. So looking at B, I'm going to find the missing side. Okay. So remember, your hypotenuse. One thing we're forgetting a lot is that the hypotenuse is always C. Okay, that's one of the first things we learned in target A, so we can't forget it now in this target. I like to keep A is A, and then O is B, so I'm not getting confused about what A is. Okay, because that's a little bit confusing there, that A is for just letters A, B, C, and that A also stands for adjacent. Okay. So I'm going to use my Pythagorean theorem to find that missing side. So I have A squared plus B squared equals C squared. A is 40 squared plus B squared equals 41 squared. Going to my calculator, 40 squared is 1600. Plus B squared equals 41 squared. 41 squared is 1681. Then I'm going to subtract 1600 from both sides. 1681 minus 1600 is 81. Take the square root. The square root of 81 is 9. Okay, so that last missing side is just 9. Right. Now in my last step, identify the trigonometric ratio of sine of theta. Right, because that's what the question is asking. So sine of theta equals opposite over hypotenuse. Opposite side is 9. Hypotenuse is 41. I'm still going to check to see if this can reduce. And it doesn't, so we'll just leave our answer as 9 over 41. And that's it. Remember, these ones are just the ones where you're using Pythagorean theorem to find that one missing side. All right, looking at number 10. Given the right triangle, answer parts A, B, and C. So I'm going to start with identify the sine of B. So again, labeling O, A, and H. Hypotenuse is across. I'm finding the sine of B. Here's my opposite side. Here's my adjacent side. Okay. Now, a lot of students use sine when they want to find this missing side, but that's why I like trying to figure out what sides I need first. If you remember, I used question marks a lot. I could go, oh, this is a side I don't know, because I don't always have to find that missing side. For this case, right, sine of B equals opposite over hypotenuse. My opposite side is 21, and my hypotenuse is 29. There's no question mark there. I already know the answer. I could find this missing side, but I don't have to, right, for this first part. Maybe we do for the second part. Let's see. All right, so cosine of A is now what I'm finding. Again, I'm switching angles. That means all of these go away. A lot of us, again, are forgetting that part of it as well. Okay, so remember, we have to start over with our new angle. So, hypotenuse is the same, opposite, and the adjacent side, right? Those are the ones that switch. So if I'm finding the cosine of A equals opposite over, that's not even a little bit right. Cosine of A equals adjacent over hypotenuse. All right, cosine is A over H. I know my adjacent side is 21. I know my hypotenuse side is 29. Okay? Again, I never had to find that missing side. Okay? So if you find the missing side, it's not going to do anything like against you. It's not going to count against you. You can find it if you want. You just don't have to. So it's kind of like a waste of time. Don't worry about it. All right, C, explain the relationship between the two trigonometric ratios and the acute angles. Okay, this is, a lot of us talked a lot about this one. This is just where the sine of an angle is equal to the cosine of, remember, these are complementary angles. Right? The sine of this one is equal to the cosine of this one. These are the same. If you could even tell me that the sine of one of the angles is equal to the cosine of the other acute angle, right? That's fine too. Okay? Okay, but you are really just remembering that relationship that the sine of one is equal to the cosine of the other. All right, that's it for B. Go ahead, look over that, and then look over target C.